Hello, and welcome back to the Cracking Fang YouTube channel. Today we're going to be solving Leetcode problem 66, plus 1. You are given a large integer represented as an integer array digits, where each digits of I is the ith digit of the integer. The digits are ordered from the most significant to least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. So if we look at an example, we're given the digits 1, 2, 3, and we should return 1, 2, 4. Why? Well, we add 1 to our digits here, so that would simply be, incrementing this 3 to a 4, which is how they got, 1, 2, 4. So that one's quite simple, but let's look at another example. If we're given the digit 9, well, what happens here? We need to return 1, 0. Why is that? Well, if we add 1 to this 9, then, it becomes 10. But obviously we can't have 10 in a single slot. The 1 needs to go to the next position and the 0 needs to stay at the current index. So we need to carry over the 1 and add it to the next value. Here there is no next value, so we simply have to insert a 1 at the beginning of the array. But if there was another one, so let's just say we had the value 999, right? What would happen here? Well, we add a 1 to this 9 and it becomes 10, right? And we recall that we need to carry over the 1 now. So we have 990 and we still have to carry over the 1. So now we have to add a 1 here as well. So this becomes 10 also. So now we're going to have 900 and we have to carry over the 1. And again, we do the same. So we're going to have 0, 0, 0. But remember, now we have the 1 carried over, so we have to insert a 1 in the beginning, and therefore we get our answer of 1,000, right? Because 999 plus 1 is 1,000. So that's the algorithm that we want to do. Essentially, if the current digit here on the, on the left, the rightmost digit here is less than 9, then all we have to do is add 1 to this and then return, whatever the array is, and we're done. It's quite simple. The only problem is when this number equals to 9, because that forces us to make it 0 and then deal with carrying over a 1 to the next one. And then if this one's also 9, then we have to keep going. So we just have to keep track of the carry. And if you've seen my problem on adding strings, where we essentially do the same thing, very similar, and then we're adding strings and then we have to deal with the carry, we're going to do the same thing here, except instead of initializing carry to 0, carry is going to be 1 in the beginning. And what we want to do is essentially, we're going to have an index I starting at the end of the array, and we're going to say, array of I, plus the carry, right? So that's going to be plus 1, or I'll just write it out. I'll get this I here, plus carry is what we want to do, right? And if this is greater than or equal to 10, then what we want to do is, keep the 0, and then the carry has to continue forward. So that's the algorithm that we want to use. Hopefully that's clear. If not, once you see the code, you'll realize exactly what we're doing, and it's super simple. We just need to make sure that we're doing the right thing with the carry, and that, if we're 10 or greater, then we just want to keep the 0 and then carry over the 1 and keep doing the addition. And in the case that we process the entirety of the array and we still have a carry, then we have to insert that 1 or whatever the carry is at the beginning. So let's do that, and we'll go over to the editor and write the code for this. So I'll see you there. We're back in the code editor. Now let's write the code. Remember that the first thing that we need to do is set up our carry variable, because this is going to represent what we need to add to the next iteration if we have a carry. So the initial value of carry is going to be set equal to 1. That way, when we process the very first index, we can just add the 1 that we're supposed to add, because remember, this problem is about adding a 1. So we're going to add that carry, and we're going to continue going from right to left through our digits. If we had a sum that was greater than or equal to 10, because that means that we have to carry over a 1 to the next level. So let's set up our I pointer. So we're going to say I equals to len, digits minus 1. And we're going to say while I greater than or equal to 0, because remember, we're going from right to left. we're going to say that the current sum is going to be whatever digits of I is plus the carry. And we're going to say that, digits of I is going to equal to the current value that we just calculated modulo 10. So this will basically, if it's greater than 10, we'll keep just the ones element. And if it's less than 10, we'll just keep whatever the value is, because modulo 10 will just return us the value if it's actually less than 10. So now what we can do is calculate the carry if we still have one. So we're going to say carry equals to the current sum that we just calculated, integer divide by 10. So this will tell us, the 10's position of our value. So for example, if you have something like 11, integer dividing will give us the 1 that we need to carry over. At this point, if we don't have a carry, we're done. We've already added our 1 and we don't need to do anything more. So we can say if not carry, we can simply break out of this loop. We don't need to go any further. If we do have a carry, what we need to do is we need to decrement our I and then go to the next digit that we need to add our carry for. So this is, you remember if the case was like 999, obviously we add the 0 to the first 9, it becomes, sorry, we add the 1 to the 9, it becomes a 10. So we make it a 0 and then the 1 carries over, and then we have to add it to the next 9. This becomes a 0, we have a 1, we have to add it to this one, it becomes a 0, and then we have to add the 1 at the very end. So we're going to do that until, we get to a point where we don't have a carry anymore, and then we can stop. If we get through the entirety of our while loop, and at the end we still have a carry, that was that case with the 999, where we just need to insert a 1 at the beginning of our digits, and we should have our answer. So we're going to say if carry, so basically if carry is non-zero, we're going to say digits dot insert 0 and carry. So, and then we can simply return digits, and that should be our solution. Let's just submit it, make sure that it works, and it does. Cool. So what is the runtime complexity of our solution? Well, in the worst case, we would have something like 999 where we need to go over the entire digits from right to left to process this and do the summation. And then we're also going to have a carry at the very end, which means that we have to insert a 1 at the beginning of this solution, right? Because 999 plus 1 equals 1,000. So we're going to have 0, 0, 0 in our digits. And then since we have a carry after our while loop ends, we'll have this 1. And remember that inserting something into an array at any point that isn't the last element is actually going to be a big O of n operation. So we're bounded by big O of n on the time. Space complexity wise, it's going to be big O of 1. Because we're not actually defining any space, we're just modifying digits in place. So that part's fine. I guess it could be big O of n if we're in this case carry, where essentially we have to insert 1, and then basically you're kind of just copying the array in order to insert it. So it could actually be big O of n here in the case that you do the carry, although I'm not sure because we're not technically defining a new data structure. I think it will happen in place. So I want to say that it's big O of 1 on the space, although I could slightly be wrong on that and it's big O of n, but I think it's going to be a constant space solution. Anyway, that's going to be your solution to this problem. As you can see, it's a relatively straightforward one. If you've seen my other videos on how to do, adding string ones or adding binary, it's basically the same idea. We're just going from right to left, and we still have this pattern of like cur modulo 10, and then the carry is, the current sum, integer divide by 10, and you're just going through the digits from left to right. So pretty standard pattern. You see this a lot on Leetcode, so definitely one to know. This is one of the easier problems to kind of get the hang of it, and then you can use it in more complex ones. So if you enjoyed this video, please leave a like, comment, subscribe. Let me know if there's any videos you'd like me to make, topics you'd like me to cover, or just general interview tips. Please leave them in the comment section below. I'll be happy to get back to you. I just need to know what you guys want to see, and I'll make those videos for you guys. Otherwise, in the meantime, happy Leetcoding, and bye.